let me start recording. Okay. So any question or any, is it clear what is L2 VPN, right? What is layer 2 VPN? What basically we achieve by using L2 VPN? And what are the different ways, data plane and control plane, for to achieve, basically to get this L2 VPN working, right? So any question on this before we move to L3 VPN? Okay, so I think I hope that it's clear. So let's move to L3 VPN, right? So L3 VPN is nothing but, in L2 VPN we were extending VLANs, right? So one VLAN to another to once from one DC or one site to other site. L3 VPN, we are exchanging routes, right? Basically end-to-end connectivity. So basically, if we have one particular route here, 1.1. Let's take it 10. Private subnet 10.10.10.0/24, right? This is, we can consider as BLR Arista, and this is HQ where we have 10.10.11.0, right? /24. And we want to, there are hosts which is 10.10.10.10, right? 10.10. And we want to communicate it with another host here, which is 11.10, right? So what basically we want to achieve is that this subnet, right? This route for this subnet should reach here to this CE device, right? So that it will forward the packet destined to this particular host, right? Or subnet. And similarly, this subnet, right? 10.10.10.0/24 should be available here, receive here, so that it can advertise any traffic for this destined to this subnet over this service provider, right? Using this service provider. Obviously, at service provider, we will have PE devices, right? PE devices, and then backbone of all the PE devices, right?
Yes.
Okay. So, so basically, L3 VPN is nothing but exchange of IP prefixes, right? And if you see here, this is private IP address, right? So if you have 10.10.10.0/24 here, same subnet might be another customer, let's say another Cisco, right? That might be using same subnet. And that also is advertising to PE devices or service provider, right? So basically, we want to make sure that the IP prefixes are advertised to other device, other side of our other DC or other side using this VPN, L3 VPN technology. Okay, so we'll discuss more how to make sure that this both are same subnet, and then how to take care of it and all that stuff. But the basic idea is to exchanging prefixes, L3 prefixes, right? From one end to it can be IPv4, IPv6 prefixes, or even multicast, right? So that also. So again, in this also we have two types of data plane, right? MPLS and VXLAN. And for MPLS, control plane is VPN v4, right? And for VXLAN, it's EVPN VXLAN. Okay. And here MPLS, we can also have MPLS EVPN data control plane. Okay. Any question? Is it clear what is L3 EVPN?
Yeah.
Okay. So now let's talk about, with reference to VXLAN, correct? With reference to VXLAN. So again, this is your one VTAP one, right? You can consider this as our Bangalore office VTAP. It is in Bangalore office and it is in HQ. Okay. And this subnet is 10.10.10.0/24, and this is 10.10.20.0/24, and we have host in that subnet locally, right? So now what we are going to do, let's say this host H1 wants to communicate to H2. What we will do is this will send the packet to the gateway first, right? So it will send the packet to the gateway. It should be, let's say 10.10.10.1 here, right? So it will send to the gateway. Now it will like look for the destination route, right? 10.10.20.10 destination IP. And it will check that, hey, to read the 10.10.20.0/24 subnet, you have to send this packet to VTEP 2222, right? It is behind VTEP 2222. So basically, what we are saying is if you want to read this subnet, you send packet to VTEP 2222 over VXLAN, right? So there is few more field here in routing table which suggests that you have to send it through VXLAN at 2222. Now, how we receive the we have first to we need to receive this route, right? We have to install this route here. So that we have to first make sure that we receive this route, install this route here on this. And then what we will do is, because now we know that this for this subnet, we have to send packet to 2222, we will VXLAN encapsulate the packet. Source VTAP IP will be outer source VTAP IP is 1111. Outer destination VTAP is 2222. We'll send it to the service provider, right? Backbone and all. They will just check the 2222 destination IP address and they will forward it to this VTAP device, right? Here we will decapsulate the packet VXLAN, and based on the destination IP, which is 2010.10.2010, it will be forwarded here. For reverse traffic, again, we need to learn this route, right? For the other side subnet, that 10.10.10.0, we should send that packet to 1111, right? Again, we will encapsulate the packet. Outer source IP is 2222, outer destination 111. Service provider will just treat it as a normal IP packet, forward it to this VTAP, and then decapsulation and done, right? So basically what we are using as a data plane, which headers we are adding for data plane traffic, ICMP traffic, VXLAN, right? So our data plane is VXLAN in this case, right? And what is the control plane? So control plane, what we will be using is EVPN VXLAN, right? Or we can also use EVPN with MPLS. So even on this device, right, as a VTAP, our devices also support EVPN MPLS. Okay. So in fact, we can use EVPN MPLS, and everything after that will be MPLS data, not VXLAN. So both is possible. Okay. We'll definitely see at least this one, right? And how this work, L3 EVPN with VXLAN. Any question if you have not understood the concept?
Just a small question. So
Yeah.
this so 10.10.20.10, right?
Yes.
For VLAN 20, this subnet, maybe I can have a host on this VLAN on the VTAP one as well, right?
Okay. Yes. So that's a good point. So there are two variants of it. Okay. If you have host here, right? Basically, see, right now the scenario what we discuss is one subnet is at one site. Okay. This subnet is at this site, and this subnet is at this site. Two different subnets, and there is no basically there is no overlapping of subnet in other sites. Okay. So in that case, where what we need to do is use L3 VPN, right? Because we need to now send the packet to, we need route for this. Okay. So that's where L3 VPN will come into place. Okay. Now there are few, see, this is very common scenario, but if I have to tell you something, that let's say there are some other, subnets here, right? Other subnets which you want to advertise to this side. So that this, and there are some other subnets here right? Which you want to advertise to this guy so that both this subnet can communicate with each other, right?
Yeah.
So
Yeah.
what you will do in that case, you will advertise this subnet to this guy. This guy will advertise it to here, and then again this will advertise to this guy. So basically both will know each other how to reach, and they can forward traffic to each other. So this is simplified way. I just narrowed it down to locally connected subnet. But actual use case will be that you have a lot of other subnets in your network which you want to advertise to other side,
Okay.
right? And similarly vice versa, so that you can communicate between that two subnets. Okay.
Okay.
Now coming to your point, right? That is which we do in VXLAN, right? So let's say this H3 host, right? Which has 10.10.20.11, right? Slash 24.
Yeah.
Correct. Now in this case, what we have to do is obviously, for this subnet also we will have SVI here configured, right? SVI 20, correct? And gateway.
Yeah.
Similarly, here you have host of H4 for VLAN 10, right? 10 dot, let's say 11. And you will also have SVI 10 here, right? So this is nothing but what? VXLAN direct routing, right? So
Okay.
now what will happen? You want to communicate between 10, 10, 10, 10 to, let's say, okay, or we can consider this, right? You want to communicate between 10, 10, 20, 10 to 10, 10, 20, 11, or we want to keep different subnet, right?
Yeah.
Okay, anyway, yeah, let's keep
H1 and
H1 to
H2.
H2. Yeah,
Yeah.
H1 and H2, right? Let's stick to that. Now what will happen? So H1 will send it to the gateway, right? Now it will check the destination IP, which is 20.10. It will route the packet. Now he knows that it is directly connected, right? Now it don't have to look at the route, or we don't have to exchange this routes, right? Because now route will be connected 10.10.20.0/24, right? Now this directly
Yeah.
connected with VLAN 20, correct?
Yes.
This route is not there, or even though you send it, it will not be installed. It's connected is what preferred, right?
Yes.
So now based on this, you will understand that, hey, this is directly connected network. I can directly reach it. I need to know ARP for this IP address so that I can craft the packet and send it. And then you will check the ARP table, right? You know that 20.10 has MAC of H2, or you will resolve it. And then you will send the packet, you route packet from 10 to 20 VLAN, and then bridge the packet over here. So this case, use case is L2 VPN, right? Why? Because now you have already routed packet within this VTAP, and now you are just bridging the packet, right? So that's why this is L2 VPN. But the one we discussed before, where you don't have this SVI here, right? And you have to advertise packet, send packet through this route, what you receive, that is L3 VPN. Again, in DCs, right, data centers, you will see most what we use is L2 VPN, right? Because generally your hosts are, VLANs are extended everywhere, correct? So you will use L2 VPN most of the time, unless and until there are some site, remote site, right, which has some subnet and you want to advertise. Let's say one use case if we want to consider is, let's say we acquired some company, right? Say BSN or Big Switch, right? Now they have their own network. We have one link, private link or whatever, L2, where we know this private subnets are also with us, and we want to advertise this subnet to other site, right? And here also there is some head office of that. So that, to achieve that, we can use here L3 VPN, so that this particular subnet, right, we can advertise to each other to make communication possible between these two, right? So that is L3 VPN. But generally in DC, we'll see most of the time is L2 VPN, because we will have VLAN extended across the VTAPs. But service provider, yeah, use case can be, more of L3 VPN, where, what will happen is here, you are Arista office, right? And this is again Arista HQ office, right? And this BLR office, right? And we have IP address, let's say 10.10.10.0/24. And here it's 11 dot or 20.0. Let's keep it 10.10.20.0, right? 0/24. Now this CE devices are not capable, they don't know, or we don't want to do anything on this, right? What we want is we'll ask service provider to give us L3 VPN circuit or extend our L3 VPN, right? We'll ask for this. Service provider will have this PE device, right? Which they will give us basically this L3 VPN. And what they will do is from this PE device, they will receive this route 10.10.10.0 on this WAF. We'll discuss this. And then they will advertise this route to P devices across this P devices through their backbone or through this another ISP. Finally, this particular route will reach to this P devices, right? And then it will be advertised here to this guy. Okay. And we will have on CE devices route installed that, hey, 10.10.10.0/24, send that packet to the P device, this guy. And similarly, this route we will advertise to P. We just advertise to P, right, through BGP or any other way. And P service provider will take care to advertise that to the other end and then to the CE device at other end. Finally, so basically, this is where service provider will use this L3 VPN at their end, and they can use again both MPLS or VXLAN, but generally they use MPLS, L3 VPN, right, as a data plane. So what they now, let's say you have routes exchange, right, through this EVPN. Across P and P also advertised to C. Now you want to ping between 10.10.10.10 to 20.10, 20.10, right, host. You send packet to the C device. Maybe this is the gateway, then it will route the P device. Now P device will use any underlying, data plane MPLS protocol, either LDP because it uses label switching, right? So either it can use LDP or ISISSR or BGP-LU, any technology, right? They do this label switching. They label here, switch the packet, and then through this label swap, it reaches to this PE device. They remove this MPLS header and then forward that packet to this CE device. So that's where they use MPLS as a data plane, right? And control plane is also whatever this route exchange information is used by using VPN v4 or MPLS EVPN. Okay. So this is use case of MPLS, right, where service provider will take care of it. And the first which one previously we discussed was VXLAN data plane, and VTEP will take care of EVPN VXLAN control plane route exchange information. Okay, yeah, any question? Let me, hold here, and any questions if it is not clear. And please ask, because this is the base of our, going forward this session. So is it clear what is L3 VPN and what is when we use MPLS data plane and VXLAN data plane or control plane, right? Is there any question or any doubt?
No.
Okay. Okay, fine. So now let's move forward, right? Let's understand that basically this one, right? Okay, so yeah. Now as we discuss here, right? that this is what our L2 VPN, right, over VXLAN. So basically what we want to achieve is this H1 is wants to communicate to H2, right? What it will do is H1 will send the packet to the gateway, right? 10.10.10.1. We will learn the MAC address, right? We will learn the MAC address of H1 and also ARP of the H1. Okay. As soon as we receive the ARP request, H1, let's say, sends ARP request for the gateway, right? So we learn the H1 MAC and ARP here. Now we want to send the packet to 2020-2010, right? So we will route the packet and we'll see that, hey, it is directly connected subnet. So we will send out ARP request for H2, right? And we'll get the reply back. So basically what we are doing is we are also learning MAC of H2 here, right? Which will be over VXLAN. We also update VXLAN address table that to reach H2, you have to send packet to 2222, right? And we also update the ARP table for H2 because we now received the ARP reply, right? So this is how we do in data plane, right? So basically, and yeah, when we have to send out ARP request, right? When this ARP request we have to send out to for H2, we have to refer the flood list table, right? What are the other VTAPs which has this VLAN present, right? Because this H2 can be on any other, under any VTAP. So we also need to know what are the information of flood, right? For all VLANs, VTAP, right? So basically to communicate end to end between H1 and H2, we need to learn the MAC address of both, ARP for both, and also flood list should be there, right? And similarly on VTAP2, right? Now, as we discuss, this is one way is data plane, right? Another is CVX, right? Which CVX takes care of it. So basically what CVX does, basically VTAP1 will send out whatever learn H1 and ARP, basically MAC learn, locally MAC learn, it will send it to CVX and CVX will forward that to VTAP, other VTAPs. So VTAP2 will know to reach H1 MAC, I have to send packet to 1111, right? And also it will also advertise flood list that, hey, I have for this VLAN 10, basically what it will say is, hey, I am part of, I have VLAN 1020 extended. So this CVX will forward the other VTAP that, hey, VTAP 1.1.1.1 has VLAN 10 and 20. So based on that, it will add the for VLAN 10 and 20, 1111 in this flood list, right? So basically we are using CVX, right, to exchange this information, and we are not dependent on data plane. That helps us, unnecessary basically MAC flooding and all that stuff, correct? Now we want to achieve this same because CVX is proprietary, right? All the vendor will not support it, and it also require different devices, appliances, or ESXi servers, right? What we want to achieve this is through EVPN, right? EVPN. Now, what we basically we want to achieve is we want to advertise this MAC information and ARP information from one VTAP to another VTAP, right? And also this flood information. Can anyone tell what can we do to advertise this information? What can we use? What is the possibilities? We want to advertise MAC, right? And ARP to other VTAP and flood list to other VTAP. Here, what can we do?
Use of MPVGP between VTAP 1 and 2.
Yes. So basically, see, so point is we can use any routing protocol, right? Any protocol, basically. See, what OSPF or BGP does, right? We know as of now what our use case is. If we want to exchange any route, which is here on this, let's say there is one subnet here, right? 2.2.2.2 slash 0 slash 24, and here it is 3330, right? So 0 slash 24. Obviously over internet we will use BGP, but within the network we can also use OSPF, right? So basically what this routing protocol does is they advertise this 222 subnet prefix to other side and 333 to other side, so that both can reach each other, right? Route can be installed. So we are already solving purpose of sending information, right? Routing information or IP prefixes from one end to another by using routing protocol. Now we also we want to achieve same thing, right? We want to advertise information from one end to another end. Instead of route, we want to advertise MAC or ARP, right? But so just underlying information we want to exchange is changed, but otherwise all other things remains same, right? We want to send information from one end to other end. That information can vary depending on our requirement, right? So my point is, for advertising MAC or ARP, right, we can use any routing protocol, right, which has this availability, provided that routing protocol supports that other information exchange other than IPv4 or IP L3 prefix, right? So we can use OSPF, we can use BGP, or we can use ISIS, right? Anything we can use to exchange this information of MAC and ARP, similar as IP prefix, provided that OSPF, BGP, or ISIS also supports that different types, right? Exchange. Is it clear? Are you getting what I mean to say?
Vishal, just a doubt. So,
Yeah.
OSPF and ISIS supports sending MAC address. How? Just for clarity.
Yeah. So see, right now, what I am trying to explain is we can achieve. See, basically, what we want to achieve is whatever MAC and ARP we have learned on local VTAP, we want to advertise it to other VTAPs, right? Correct. Like prefixes we use to advertise using these protocols. So our requirement is to advertise more information, right? Now, if we are already using this different protocols for IP prefixes.
Yeah.
So if this particular protocol supports advertisement of other than IPv4 prefix information, if this supports or if this is extended, right, then we can also use any of this.
Okay, got it.
Right. So I am saying that if we have that possibility, then we can use any of this, right? Now it comes of the choice. Let's say everyone is supporting that advertisement of other than IPv4 prefixes or IP prefix, MAC ARP. Then now it comes that which one we should use or choose, right?
Yeah.
So can anyone tell me for this scenario, right, which protocol you will choose and why? Let's say OSPF, BGP, or ISIS. You have given 3 choices and assume that all 3 is supporting this advertisement of MAC ARP, right? But considering scale of internet and all this, which one will you choose out of these 3?
BGP.
BGP, right? What is the reason for BGP?
Because it can scale any number of routes.
Okay. Yeah, means okay. Yeah, scale any number of routes. Why it can scale any number of routes? What is the advantage over OSPF, right? Let's say in OSPF also means you can send a lot of routes. Obviously, why BGP has upper end, right?
Because in BGP we can advertise the routes. We can.
Yeah, you are on right. Means basically we have more control, right?
Yeah, more control on that.
More control. correct? Basically, we can using route map, we can easily filter packets or routes. If we don't want to out of 1,000 or 10,000 or 1 lakh route which service provider sending us, if we want to install or receive only 10 routes or 1,000 routes, that control is there with BGP, right? Easily. However, with OSPF, that is there, but that's one is difficult, right? And that is also only at border router, area border router, right? Because within area you need to have all the routes, router should have same routing table, right? So basically it's difficult, correct, to filter or control the route. Anything else? Scaling perspective, obviously this is one. Anything else?
Supports of different address families in BGP, so different traffics can be segregated.
Yes. So that is another good point, is that it supports different families. What does that mean? Different families is what we are talking about, right? BGP supports obviously IP prefix, which we are using since long, but it also supports different other families like what we want to achieve, MAC, ARP, right? So that's why we can use BGP to advertise whatever we want to do for L2 VPN. But again, this is we developed, right? We developed BGP to support all this, considering that BGP is better than OSPF or any other protocol in this type of environment, right? Internet. But what do you think that what is the other quality of BGP which is making it best in comparison with other protocols? One is obviously route control, right? Which is very much important. What else? Okay. So internet, we are talking about how many routes?
Millions of
Lakhs of routes.
Yes, millions of routes, right? Now think of, and as you know, right, this millions of route, and there are a lot of churn in routes, right? Continuous, right? Because you don't have control. Do you have any control? Let's say one particular, some routes are churning continuously up, down, right? Do we have control? No. But with BGP, we are able to manage it quite. But what, just think about OSPF. If you have OSPF with millions of routes and churning, what will happen?
It will keep on calculating USPF
Yes,
table again
right.
and again.
Correct. So basically you can understand, right? Why BGP, even that's the reason why BGP over for internet and not OSPF or other protocol, right? Similarly, if you extend our same info, this thing, right? MAC and ARP. Now consider you have how many hosts can be in one big DC or one big organization. How many hosts it can be have? It can have 100,000 millions of hosts, right? If you think of big DC. So that many of MAC addresses, ARP information you have to exchange from one end to other end, right? And if you see churning in that, again, you will end up with this, right? Problem. So that's the reason, right? Why you at first place, you will choose BGP for this type of, right, exchange. And then we make BGP capable enough, right, by advancement, so that not only IP prefixes, it can also send information like MAC, ARP, or there are a lot of other information which we can exchange between these two. And that is called MPBGP, multi-protocol BGP, extension of that is, right? MPBGP, multi-protocol BGP. Okay. So have you now, are you clear why, we choose BGP over other protocol? There are other OSPF, and that also, ISIs also support that at some extent, exchange of the other information. But yeah, widely used or most of the time what we see is MPBGP, right? And the reason is what we discussed, route control, and this all about the way BGP handles this churnings, routes exchange. And by extending this with multi-protocol BGP, we should be able to solve our purpose of L2 VPN, right? MAC and ARP and other information. Any question?
Yeah, Vishal. So, when you say the scalability of PGP with several routes, the routing table of the device is the factor, right? So, the when you mean by scale, is it the how what does that specify exactly?
Yeah. So see, first of all, when I mention about scale is, first is protocol itself should be able to handle millions of route, right? First, see, first bottleneck is protocol itself should be able to self-sufficient to handle millions of routes. Then next step comes is with device, whether device can handle it or not, right? But first of all, let's say you have millions of route and there are continuous churning and all, which protocol can handle this situation better, right? So that is BGP, right? And we also have very much control over the route filter. Let's say this service provider might be sending us millions of route, but we have control which one to install in our device based on our device capability. If my device is low end, what I will do is I will just install default route, accept default route, even though it's sending me millions of routes. Or I will accept only default route and few other routes which are important to me, right? Yeah, even though we are receiving millions of routes. So that all we can easily, control with BGP rather than OSPF, right? And even though at one point of time we want to receive full million or multiple million routes, BGP, considering on internet there are a lot of churnings, BGP should be able to handle it more gracefully, or will handle more gracefully compared to OSPF.
When we mean by churning, say suppose if a neighbor goes down the table, BGP table stays intact without any withdrawal of the routes. Is that the exact thing you're saying?
Yeah, churning means, let's say, then one particular site goes down, right? It has public subnet 2.2.2.2. So obviously this site will withdraw that route from the advertising, right? It will stop advertising. So BGP again, then that will be updated to all other BGP peers, right?
Yeah.
Yeah. So that is what my point about churning is. So considering internet routing and also MAC, and what we are looking to advertise MAC and ARP information, right? Which can be again hundreds or thousands, hundred thousands. We can use BGP as an underlay protocol because it has more, it can handle this route up, down and all that quite better way compared to other protocols. Is it clear? Any question? Okay. So now let's discuss about, MPBGP, right? So how we are going to achieve this using MPBGP. So MPBGP, which supports all the different address family, right? Which is nothing but IPv4 unicast, multicast also you can exchange, IPv6 unicast, IPv6 multicast, VPN v4 routes, that is L3 VPN routes, right? Prefixes, BGP, LU, EVPN, and multiple, and also exchange of MAC address, ARP, flood list, right? So all this we can, use by using MPBGP and exchange of IP prefixes for L3 VPN. Okay. So basically MPBGP, using this MPBGP, we can advertise not only the IP prefixes, but any other protocol information, other information as well, right? Now, how we do that? Let's check the BGP. Okay, so let's first understand the BGP, basically this exchange, right? And open message. So basically when BGP comes up, basically this exchange first open message, right? So let's look at the packet capture, right? And I try to identify how MPBGP is different than our normal BGP, right? What are the fields which are extra, right, in MPBGP? So this is a Ethernet first, then IP, and then TCP, and top of it there is a BGP, right? Open message, correct? My AS number, hold timer. This is what all the information exchange in open message, right? And then let's extend it to this. Now this is also, if you remember open message of normal BGP, right? We have graceful restart capability, route refresh capability. So this is all there, correct? What is extra in MPBGP is this thing, this field, multi-protocol extension capability. So basically, when one device, right, wants to establish MPBGP session with another device, it will tell, both of them will tell to other side in open message, hey, I want to establish MPBGP. I want to establish MPBGP session. Basically, I want to bring up BGP to exchange some of the information which are not IP prefixes. Other than that, okay. Now it will also tell what type of information I want to exchange in that, right? So that's where it comes AFI and SAFI. So what is AFI and SAFI? So AFI is address family interface identifier. AFI, address family identifier, and SAFI is subsequent address family identifier. Okay. Now what is AFI? AFI is, there are different numbers and that number represents IP protocol. Okay. So number one is what? IPv4. So basically, let's say you want to advertise IPv4 prefix, unicast, right? Normal hour 11110 unicast. Okay. So what you will choose in that AFI field? IPv4, which is 1, right? So 1, right? That is AFI. And in SAFI, what you will choose? It is a subsection of that. So, okay, you want to advertise unicast, but what type of packet, right? Unicast, multicast, or what type of packet? So that's how you will, you will choose from here, SAFI. Okay. So if we want to advertise IPv4 unicast, so you will choose this SAFI as well, one, right? This one. So what does that mean? I want to advertise IPv4, which is a AFI, and SAFI is network layer reachability information for unicast forwarding. So that's why it is 1. If I want to use IPv4 multicast, basically multicast route, right? Then I will choose AFI as 1 and SAFI as 2. 2 is for multicast forwarding, right? So basically by choosing this AFI and SAFI, we are saying that, hey, I want to exchange this type of route. Okay. So if you go, we go in more detail of AFI, what are the different types? IPv4, IPv6, right? Then IPX, Apple Talk, these are all protocols, right? Which we use. The interesting one which we want to is L2 VPN. So basically, if we choose FES 25, basically what we are saying is we want to advertise L2 VPN related information. What does that mean? L2 VPN means MAC address, ARP information, flood list information, right? So that's why in this case, if you see, because this is L2 VPN MPBGP, we have chosen FES 25, layer 2 VPN information, right? So layer 2 VPN information, then there are different other information you can choose or advertise. So if you can understand, MPBGP supports all this, right? All this protocol information advertisement. And other than that, also subsequent address. So now I want to advertise L2 VPN information, MAC ARP. SAFI, I can all further choose, hey, I want to use it using EVPN or BGP LS or ISISSR, right? Because L2 VPN also we can advertise using different type of ways, right? Different ways. So again, you are choosing that, yeah, we want to do L2 VPN information MAC and ARP, but that also using EVPN, not by using BGP LS, right? Or ISISSR or some other protocol, right? So basically, what we are saying is, when we send out BGP open message, now this is called MPBGP, right? So we are adding MPBGP extensible capability, where we are saying that, hey, I want to exchange layer 2 information MAC ARP using EVPN. Okay. So is it are you getting this? What is the difference with in comparison with normal BGP?
Yes. But
And yeah, go
Vishal,
ahead.
just
Go
a
ahead.
quick question. So in this open message, right, we are advertising the capabilities,
Right.
but there should be some configuration as well, right? That it makes it send out that particular
Yes,
information.
that's right. Yes. So we will look into when we, that what configuration will make this, right?
Okay.
So basically in BGP neighbor, when you write BGP neighbor, then AS number, then neighbor address, right?
Mm-hmm.
You also have to write, BGP multi-protocol extend. Basically, you want to support this multi-protocol MPBGP. So that command also you will write.
Okay.
Yeah. And then only it will start advertising this capability. Okay.
Mhm.
Okay. And then
But this will be under the address family or
no, so multi-protocol extension will be on global, but after that, when you configure, right, at the address family that, hey, I want to use L2 VPN, EVPN, then you will configure address family L2, basically EVPN, and then you configure WARF and that, then it will understand that, hey, you want to advertise this information and it will select this. Okay. So we'll see that. But obviously, definitely, this will be based on configuration. Okay. So how it will know BGP protocol that I have to exchange MPBGP information, and that also L2 VPN, right? Using EVPN, AFI, that is all based on configuration. Is it clear?
Yeah.
So let's say this one VTAP has sent to other VTAP, and in reverse also we can see that same capabilities are, again, basically the other side also accepted that, hey, yeah, it will also send in open message that, okay, I'm ready for FE and SAFI of this, right? I'm ready for MPBGP basically. Okay. So that's how, this MPBGP, this is how basically by using MPBGP, we can achieve what we want to do, right? So, okay, so let's discuss now. So we discuss about open message, right? Now let's discuss. So is there any question about open message? So right now I just want to point you out about this MPBGP field and FE and SAFI. Okay, there are other fields which we will gradually discuss, but right now for open message, this is what I want to point to, basically want to you to know. Okay, so if there is nothing on this, then let me show you the update message. Okay, so this is the one and packet 5. Yeah. Now let's look at the update message, right? We understood, this guy, basically open message, and how we exchange information that, hey, we want to use MP BGP capability, and these are my information I want to exchange using MP BGP. Now let's look at the update message, how it is different from normal MP update message. Okay, so okay. So here again, I extend up to the update message, BGP update message, right? So type 2, and then there are different BGP attributes, origin, IGP. We know we use in BGP as well. AS path attribute, that also we use, right, in our BGP. So these two are, we know. The what is extra is MP reachability and LRI. Now, have you seen this or related to this in BGP? Instead of this, what you have seen in BGP update message?
Reachability NLI and unreachability NLI.
Yes,
NLRI.
yes. So basically, what is difference here? It is MP, right? That is added multi-protocol. So BGP also has reachability NLRI, but here it is MP reachability NLRI, and same it will be MP unreachability NLRI, because we are updating multi-protocol information, right? So that's the difference. And another thing what you will notice is extended communities, right? Which is you might have not seen with BGP, normal BGP. So now let's expand on this MP reachability and LRI. This is all same, right? Non-optional, and what means what type of this route it is, and MP reachability type code. Now this is what is extra, right? AFI and SAFI information. So we have seen this on open message. This is also included in update message, that what type of routes we want to exchange, right? AFI and SAFI, right? Then next hop is also there in normal BGP, right? That you have number of routes, and next hop will be this. You have to send all this traffic to this next hop, right? So this is also there with that. But in our case, it will be VTAP IP address, because we want to advertise MAC learn on this VTAP, locally learn MAC or ARP with this VTAP 1111 under this. So our next hop will be advertised route will be 1111, this VTAP IP. And what are the NLRI information, right? So it is MAC advertisement route. So basically, instead of IP prefix, we are advertising this MAC address and ARP. So this is MAC plus IP combination. So this is ARP information. The other field we will discuss. Right now, I just want to show you that how we are exchanging ARP information. Okay. Using NLRI. So this is ARP information, and this one is only MAC information. So basically here, what we are advertising using update message, that behind VTAP 1111, there is this ARP learn, which we are advertising as a route. And similarly, that MAC we are advertising, right? We'll understand all this, right? But just wanted to make understand, explain, show you that this is how we will advertise the, instead of routing information, we are advertising MAC and ARP information with next hop as 1111. Okay. Any question?
Yeah, Vishal, what about the like IP routing if you want to advertise the IP prefix?
Yes, that also will be there. You will have multiple update messages, right?
Hmm.
Or yeah.
So
So
it will be added in this one itself, like there will be an LRA, or it will be a separate.
it will be separate NLRI, because if that again depends, yes. So it will be separate NLRI. So this is only for, MAC and our L2 VPN. See, basically this is L2 VPN information you are forwarding, right? So
Mm.
this will have only, this NLRI will have only L2 VPN information. You want to advertise something, IP prefix normal, then it will have different update message.
Okay.
Or within this different MP reachability NLRI, which we will again see with combination of multiple. Okay. Let me see if we can find, but definitely, yeah, that also we'll see at one point where we have multiple or within that we have multiple information that we'll see. I have to find that packet, but yeah. So basically what I want to explain you is difference between our normal BGP and update normal BGP and MP BGP. What are the fields which will be different, right? And how we are exchanging this information using MP BGP. Okay, is it clear? We'll discuss more about this, Phil. Don't worry about this. Just wanted to make sure you understand AFI and SAFI in open and update message as of now. Okay. Yeah, and this is what we want to make you understand, that MP reachability NLRI, AFI and SAFI in update message as well as in open message, right? Which will decide that what information we are sending. And similarly, we have unreachability NLRI. So let me show that packet to you. It's 21, right? So this is MP unreachability NLRI. So when you want to withdraw route, right? Let's say that particular MAC address which you advertise, now it is flushed, right? And ARP is clear, age out. What you will do? You have to send out VTAP1 has to send out withdraw routes like we send out in IP prefixes, right? When route is no longer available locally. So that's what we use MP unreachability NLRI. Again, you will have same field AFI SAFI, that what type of information you want to withdraw. And then you will also mention that, hey, I want to withdraw this MAC address, right? Remove this MAC address, because initially I send that, hey, this MAC address you can reach through me, VTAP1, but now it is no longer with me, you withdraw this route, MAC address, right? So this is MP unreachability NLRI. Okay. Any question?
Vishal, so the churns, when you mentioned that there is less churn in BGP, so there is withdrawn routes, right? But in a LAN network, there is a huge number of churning, as you say.
Yeah. So my point of churning means what my point was, that it's not that BGP has less churns. Churning is going to seem, let's say there are 100,000 routes, right?
Yeah.
100,000 routes. If let's say 1% route or 10% route are churning, basically flapping, right? Every minute, that means 10% of this is this much, right?
Yeah.
This is there. This is going to be there in every network, right? So I'm not saying that BGP will have less churning. No, it is going to be whatever it is there in the network or over internet. What I want to mean to say is BGP will handle this churning of routes, let's say per minute, 10,000 routes more gracefully compared to OSPF or IS.
Okay.
So basically, the way BGP is designed, if there are 10,000 routes are flapping every minute or every second, BGP will be able to handle it more gracefully, or basically without impacting, lot of other without impacting traffic and all, compared to OSPF or ISS. Because if in OSPF, let's say that this many of routes are continuously changing, right? The way OSPF work is it will recalculate database, right? It will try to find shortest path. So continuously it will be processing data, because there are a lot of routes it has to update, recalculate shortest path and all that, right? So the way OSPF is designed, it will be very difficult for OSPF to handle this many of churning of routes. However, BGP, what it does is it just sends out, withdraw route, right? And then the other side will take basically handle that. There is no basically, calculation, complex, SPF and all what OSPF does with BGP.
And also the BGP update message it's not frequent, right? I suppose it.
Yeah. So as we know on internet, we have that, I forgot the terms, right? That if particular route is flapping multiple time, it will freeze it, or basically I forgot the
Graceful
Dampening.
restart.
Damping, route damping.
yeah, yes, route dampening. Yeah, right. So these are all that features also with BGP, which will again reduce this flapping of routes over the internet. Right. So yeah, but good that you asked this question so that it's everyone's clarity that yeah. So the reason why we choose BGP over internet or for EVPN is that it can handle churning of routes more better way compared to other routing protocols. Okay. Any other question? Okay. Okay, so I just want to, before we end up for today, I just want to bring you to more fields, which we will discuss again definitely in next, but just wanted to show you, right? So that is this field. So we also have route distinguisher. If you see here under MP reachability, let me just stop all other. Okay. So under MP reachability NLRI, right? This NLRI field, right? Where here we have AFI-SAFI, and under that this NLRI field, we have this route distinguisher 100. Okay. So we also have this route distinguisher RD. We call it as RD. Okay, in NLRI information. And there is one more thing, which is route target RT, which is again 100 in this case. Okay, so these are two more fields which we will discuss in next session. Why, right? Why? But this is the new fields like AFI-SAFI, which will be in MP reachability, basically MP BGP. Okay, so just right now want to point you about RD and RT, right? Why we need this and what is the use case of it, we'll discuss in next session. Okay, any question? Okay, then I think we can stop for today, and I'll upload this session. Thank you guys.
All right. Thank you. Bye bye.
Thank you, Sean.